One of the things that I recently came to terms with about the nature of the sun and the darkness of outer space is that we only perceive light in a very, very limited frequency. We have this very, very narrow band in a much broader band that is the visible spectrum that we see. And if a photon is of a higher energy than ultraviolet, or it is a lower energy than infrared, we don't see it. Even if it's in the ultraviolet or infrared bands, we don't perceive it. And the energy of these photons, of these particles, is sufficient to actually penetrate what our matter is. And so there is this relationship between energy and mass that is component, that the energy actually travels through mass if it's of a certain energy. If it's a high enough energy, it travels right through our matter, our mass. And so we don't really even have a way to necessarily detect it if it's that type of energy. And when you look at the sky at night, you notice that there's a lot of dark places. You notice that there's a lot of blackness in outer space. And there's only these little dots that we can actually see. What if that darkness actually is a form of energy that travels through us? And if you look at the sun, there's the most interesting phenomenon of the sunspot. And the sun has these very, very active regions that when they get hot enough and active enough, turn black. And it's assumed, and it's still, if you check Wikipedia for what a sunspot is, it will tell you that these areas are cool spots. But if you look at the X-ray band, if you look at an X-ray image, you'll find that those areas are giving off radiation that goes right through the infrared detector. And so they might be technically cooler, but in some sense they are the very hottest parts of the sun. And as far as energy goes, electromagnetic energy is a function of the frequency. And so as that frequency gets higher, technically the energy is also greater. The energy the particle carries with it is a function of its frequency. And so these black spots on the sun are not black because they're cooler. They're black because they're too hot for us to see. And that we see black on the face of a luminous sphere is more an error with our perception than it is a spot on the sun. But if it was possible for us to perceive all frequencies of electromagnetic energy emissions, it might be the case that we would be nothing at all.